In Python, all objects respond to comparison operations, such as test of equality or relative magnitude in case of integer values, for example. In fact, in Python, the comparison inspects, or the comparison operation inspects all parts of the object, including deeply nested objects, before determining the result. If you're comparing two lists, so the comparison of list object compares all components within the list, and the first difference found along the way will determine the result of your comparison operation. So let's take a quick example of this, right? Let's create a to list here. First, I'm going to just create this list, and let's nest this list as well. So I'm going to say one, nest it with a tuple, 2, 3, 4, and I'm going to create another list here, 5, 6, right? So now I have a list which has integers, it has tuples, it has a nested list within it, and I'm going to do the exact same, create exact same list again for L2. In fact, just to go along with practicing our previous commands and such, I'm going to actually create a copy of this, right? Okay, so now my L1 looks like this, and L2 was also the exact same list. So if I said L1 equals L2, right? Notice we were using double equal for test of equality, because we use single equal symbol to create an assignment of some sort, right? So double equal to test of equality, and this pretty much follows the same principle that does in all other programming languages, which is be C, Java, Perl, PHP, what have you not. So if I do that, it returns true, right? It returns a Boolean operation or Boolean value that says whether or not your operation was successful or true or false. So the comparison between two lists is true. Now there's also an is operator in Python. So if I say L1 is L2, that returns false. Now why is that? So the is operation checks for the identity of two objects, or and not the equality of two objects. So quite a big distinction between equality and identity. Remember from our previous example where we said A equal to 2 and B equal to A, right? So in this case, A and B were are shared objects, or they're pointing to the same object within the memory. In this case, they're equivalent, right? They're not just, A is not just equal to 2 or to B in value, but A is also B, or is identical in terms of pointing to the same object within the memory. So A is actually B as well. And for most of the time, I would say 99% of the time, you're not going to use the is operation, right? You're most likely to test for equality, and you're just going to use double equal sign. Is mostly reserved for some special cases. Say for example, you are running someone else's code, and or working in a team, right? And your function modifies the data that's passed to your function, whatever that function does, and you want to use the is operator to test and make sure that the data that's passed in is not identical or is not a shared object to something else that might be already in the program. Because if your function's modifying this particular variable or this particular object, it may have down the stream unexpected results that you didn't expect to have. So you use the is operator to test, and if it is equivalent to something else in the program, you might want to make a copy of it like we did over here before you continue on and modifying your code. So similar to our equal to or equality test, we also have less than, greater than comparison objects, or less than, greater than operations to compare whether or not one value is less than the other or greater than the other, right? So let's create another list here. I want to recreate our list here. So I'm going to say list 1 is equal to 1, and again I'm going to create a tuple 2, 3. just so we get the idea of how nested objects are also compared in Python. And I'm gonna call this B4, I think, yeah. Okay, so I have two lists, L1 and L2. Now I can say, is L1 less than L2? And that will return true, because, you know, notice again, when we do these comparisons, the first difference found determines the result, right? So in our list 1, the first difference between L1 and L2, well, these two values are equal. B is also equal, and 3 is actually less than 4, so it returned true. Yes, L1 is less than 2. But if I were to flip this to say, is L1 greater than L2, that returns false, because 3 is not less than 4, right? And again, if I say L1 equals L2, that will tell you that that is false as well, because they're not equal. So in general, numbers are compared just by relative magnitude. You know, if A is equal to 2, B is equal to, so I said, is A equal to 2? And it said true, because A was assigned to 2, right? So if I said B equal to 3, well, that's false. A greater than B, that's also false, because 2 is equal to 2. So in numbers, you're comparing relative magnitude. And if it's floating point numbers, then it still holds, right? So A is greater than 2.5, which is false, because A is set to 2. 2 is not greater than 2.5. But is A less than 2.5? And that is true, right? So that pretty much follows the logic that we've already learned. Excuse me. In case of string comparisons, it's kind of similar to list. In case of strings, there are two levels. First, it checks for your cases, whether it's capital or lowercase, and then secondly, whether or not the each individual letter is compared between two strings to find out whether it's equal, less than, or greater than. As far as list and tuples, we already know that they compare from left to right recursively to every nested object and returns the first difference that is found. In case of dictionaries, the equal to will or the identity operation, or double equals, it will return true if every single key and pair value within two dictionaries is true. Right. So let's give you an example of that. So if I have dictionary 1, A of 1, B of 2, and C of 3. All right, and dictionary 2 is equal to A of 1, there it is, B of 2, and C, let's call this 4. Alright, so if I say D1 is equal to D2, well, it's false. It's not, because the key value pair for C is 3 and 4. Now the less than and greater than operations work fine for dictionary in Python 1, or I'm sorry, in Python 2, but not so much in Python 3. So there's quite a lot of overhead when you do these inequality operations, or less than and greater than, or magnitude operations for dictionaries. And quite frankly, I can't think of a single reason, or I can't think of a single instance when I have used the less than or greater than value to compare to dictionaries. So in Python 3, you might get an error message for less than and equal to operations, but dictionary 1 equal to dictionary 2 still holds true in Python 3 and Python 2. So let's also compare mixed types. So let's say you have a number in your in a variable stored, right? So let's just call this A is equal to 11, and you asked the user to type in a number, and say they typed in 11 as well. But when you read in from a file or from a command prompt, that gets converted into a string. So if you were to do, let's just simulate that by saying B is 11, right? So now if I say A equal to B, well, that will be returned false. It's because A in this case is an integer, and B in this case is not an integer. It's actually a string because it's surrounded by quotes. And the greater than and less than operation still works in Python 2, but not so in Python 3. So if you were to do, if you were to compare this in Python 2, that is true, and in fact all these values are going to be true, because in Python 2 there's some sort of an arbitrary rule set for strings which makes all strings to be greater than the numerical values. So no matter what value I put in within a string, it will always return true, and if I flip this around, that becomes false because 11 is not actually greater than some string value. Oh, and in Python 3, if you were to do the same operation, you get some sort of an error, something to the order of that you can't do int and string comparisons, right? However, you could convert the integers or strings into a different type. So you can convert strings into integers or integers into strings, and then perform the action if you want. So take our example where user types in a value, if you're expecting it to be always numbers. So even if they typed in a string of 11, you can wrap the input around an int function and convert the string into an integer. So if I could say B is equal to int of 11, and now if I said A less than B, that would be false. If I say A equal to B, if I can type, that will be true, because now we've converted the string of 11 into an integer by typecasting using the int function. Okay, so let's move on to, before we move on, there's also a not equal to operator, which is semicolon equal to, as a syntax goes. So if I say A not equal to B, that will be false because A is equal to B. That's pretty much telling you to test for not equal as opposed to equal. There's also greater than equal to, and less than equal to if you are trying to compare two magnitudes for less than or equal to values, or greater than equal to. We can also chain these comparison operations together. So let's give you an example. We can say 1 less than 2 less than 3, right? Which will return true because all those values are less than each other. Excuse me. Which works well, but it doesn't make great for readability. I really don't like these kind of comparison operations where you're doing more than 2 values being compared in a single statement. And it also, what would happen if I wanted to compare 2 different things at the same time, right? I wanted to say, for example, in a class, I want to get all names that are less than, all last names that are first half of the character set. So they're all last initials are less than M and have a grade greater than 75, right? So there are 2 different types. One is a string comparison. The other one is a numerical comparison. How do you do that? Well, you could do something like this. You can say, if my last name is a string, I can say last name of 0. So that will give me the first letter or last initial. If this is less than M, right, and I would also do dot lower here to make sure I get the lowercase of my last initial. That way the string comparisons are always case sensitive, so I'm comparing equal cases here. And so I could do this equals grade greater than 75, right? So something like this. So that says, does this equate? Does this comparison operation, what does that return? In this case, if it returns true, then it would say is true equal to whatever this returns, if that is true as well. So if it says true equals true, which will return true, and then your entire statement here returns a true value. Or if any one of these parts are false, then your entire statement will return false. So for that, we could actually use something called an AND operator, or AND statement and OR statements as well. So we could say this instead, we can say last name 0, and assume these are all same cases, and grade greater than 75, right? So here this one makes it a way better to read the statement, and it's always best to write excuse me, better readability statements even for long-term use, right? So for AND statements or AND operator, all parts of the statement have to be true to return true. Right? So the left-hand side here and the right-hand side have to be true to return true. And you can chain this around to as many other operations you want to. Assignment was on time, right? So to speak. So that kind of stuff. So that's for AND operations. Similarly, you have OR operations. You can say last name is less than M or grade greater than 95, for example. Right. So this will return true if either one of the parts of the statement are true. So if the last name is less than M, in my case, my last name starts with a B, so my last name, last initial is less than M, which is true, and let's say if I have a grade of 75, right? So this part is false, but because of it being an OR operations, it will return true because it only needs one part of the statement to be true, right? So I'll give you an example. Now this will throw an error because we don't have this variable set, but we can say 1 equal, if I can type, or 1 equal 2, right? So 1 equal 1 is true, or 1 equals 2 is actually false, and true or false is true. And for AND operation, that returns false because all parts have to be true. So if I switch this to 2, that will be true. Similarly, there is a NOT operation available, which in essence just negates the Boolean value that's returned. Right? So if I just simply put a NOT in front of this, so it says not that, and that will return false, saying whatever the Boolean operation is for the rest of the statement, negate that using the not value, and you get false. So not 1 is false, not 1 equal to 2 will return true because 1 equal to 2 returns false, and not false is true. And that's it for comparisons and various operations. So we'll see a lot more of these when we cover if statements and loops and conditions.